So this session is mainly focusing on the application of the information technology of the computer science in one of the civil engineering domain of transportation engineering. So we know that day to day we are using many applications, like starting from the railway ticket reservation and tracking of trains. So we know the common applications, as well as we are booking taxis. Yes. So all this, or we are using the information technology tool. So in this session, we are going to see a brief introduction on the transportation and economic development. How transportation influencing on economic development. So how ITS is helping in the development of economy. What is the definition of ITS? That is, I am framing transportation engineering plus information technology. We generally call it as the intelligent transportation system. So the definition we are going to see. And the historical development of the intelligent transportation system. And a few applications in India as well as in abroad. This is what my plan for presentation. So the first of all, the transportation and economic development. So both are more interrelated or intercorrelated, you can say. A country's economy, the soundness is basically depends on the sound transportation system. We can see many examples around the world. For example, USA or European countries, the basic, they have very sound transportation system. That's why they are in economic also, they are very sound. It is like a backbone for any country's economy. So transport and economic development of a country are closely related. If you draw a graph between transportation development on y-axis or the x-axis and the economic development on y-axis, you can get a very linear, positive linear relationship. In other words, I can say the transportation is acting as the engine and circulatory system for an economy. What is a circulatory system? So goods, especially goods and people, are moving from one place to the another place. Okay, it is like a circulatory system. Okay, you can see in human body, we have nerves. Okay, so blood circulation is good, then a person is said to be a healthier person. Similarly, for a country's economy, the goods movement as well as the people's movement should be in good. Okay, the country should have a good rail network, air network, as well as road network. So the movement of goods without any hindrance, it should go very smoothly and fastly, efficiently. Then the economy is said to be a healthier economy. As the economy of a country grows, more goods are produced and people travel. So it is generally we express it in GDP, the gross domestic product. So more goods will be produced, so they consume. That means in one place the production may be happen, that need to be distributed to all over the country. Then only the economy grows. So for that, the transportation is the backbone. That's why we say that the demand for transportation is not a direct demand; it is a indirect demand. That means the demand for goods increases, then only the demand for good transportation system increases. It is not a direct demand. So India's economy, for example, is growing at 8% per yearly on an average, and its road transport is also growing 10 to 12%. Here I am only quoting only the road transport. Similarly, the air, rail, so all mode of transport, water transport, all growing parallel. Air transport is growing at a rate of even faster, like air mode. And Indian government of India is focusing on developing the airports in tier 2 cities. So the people prefer to travel air mode so that they can save more time. So that time can be used for the economic development. Rail transport, water transport, pipeline. Pipeline is also one of the mode of transport, are also growing at a higher rate. So we know that India is having a very large rail network of around 80,000 kilometers. Similarly, the water transport is also now keen. Government of India is very keen to develop. And pipelines, especially the petroleum gases, are transported through pipelines for longer distance without depending on the actual mode of transport. So that is also comes under the transportation. So the existing stock of roads, railways, ports, ports in India, airports, pipelines are proving inadequate to meet the growing demand. So already we are developing the roads. We are widening the roads from 2 lane to 4 lane, 4 lane to 6 lanes. National highways are widened. Expressways are under construction. The bullet trains are under in progress. Right. So ports also developing. So even though we are lagging, that is not pop up with the demand. So always the supply should be at least equal to demand. But here in our country, since it's ours is a populous country, the demand is surpasses the supply. So the capacity augmentation is proving to be very costly and time consuming. It is soon overtaken by traffic growth. So in India, in a majority of the cities, the metros are under construction, bullet trains are constructed, the roads are widened. It takes more time. You take the Chennai Metro, it is past 10 years. Chennai Metro is under construction, and also it consumes a huge, tremendous funding. The fund is required. As I said, the four-laning program actually initiated in 2001 under a program called National Highway Development Project, where the many 2 lane national highways were widened to 4 lane, similarly 4 lane to 6 lane. So there is an excellent project. And also they started constructing the expressways, the access control expressways. That means the roads are not directly connected to the main road. It is actually connected using a ramps. So the vehicles which are entering to the expressway, it was almost matching the speed of 120 or 100 km/h, so that it will smoothly merge with the upcoming traffic. So these are the few photographs of our expressways. In the second photograph, right hand side, you can see the entry and exit ramps. So this is a exit ramp. So here entry ramp. So the vehicle which is coming in the ramp, so they accelerate and match the speed which the vehicle upcoming to. And it is fully protected. So the vehicle or pedestrian cannot cross at any point. So it is only accessed only in these points only. These innovative approaches are needed to optimize the investment. So now I am coming to the point. So we are making a huge, enormous investment on these road and rail projects. So this investment should be properly utilized, effectively utilized. So for that, for this application of information technology or computers or management. So the application of information technology in transport is receiving worldwide attention under this context. Even starting from civil engineering, planning up to execution, even during the operation, we are depending on the computers. Okay? So it saves a lot of time. So a new concept which is universally called as the intelligent transport system is finding useful applications. So if we use these IT tools properly, definitely our India's economy also grows very fastly. Here we are going to see the definition of intelligent transportation system. In this picture, you can see the vehicles are moving on a junction. There is a grade junction, and there is arrow mark is given in between the vehicles. That is the vehicle to vehicle interaction. So these are new technologies, which is upcoming technologies, I can say. And soon we are going to see on our roads. And the signal controls are happening based on the queue length. So this is already existing. Okay, so the parking, you can see the EV charging parking lots. So where the parking facilities provided along with the EV charging stations, right? And any emergency vehicle ambulances are coming, that will be communicated to the upcoming, that's next vehicle. So automatically they give way for the emergency vehicles. So there are so many markings are given, like communication, which is happening between a tower and communication. There is a traffic control center is there. So they communicate between the signal and the traffic control center. So this is the overall definition of ITS. So what they are saying is the intelligent transportation system or applications. We are using applications which aim to provide smarter services for transportation and traffic management systems by using information and communication technologies to improve the efficiency. So quickly you need to transport. So the efficiency, economy, save the money, safety, no accidents, and sustainability of transportation networks and thus reduce traffic congestion with enhanced drivers' performance and travelers' experience. So this is what the broad definition is given. It not only ensures the efficient, fast economy and safe movement of goods and people from one place to the other place, it also ensures they enhance the driver's performance by different kind of goods. So historical development of ITS. So here we are going to see the three phases of the development of intelligent transportation system. They described like this: phase one, starting from 1960, way back to 1960 to 1980 is they designate as phase one. Whereas phase two is starting from 1980 to 1994. Phase three is from 1994 to. So anyone guess why they this kind of division is given? Okay. So the phase one basically based on the radio communication, the radio technology, the frequency modulation technology was used from 1960 to 80. That is a own kind of period. Okay. The second phase, the 1982-94, the electronics and communication played a major role in operating traffic and all. So that is they designated as 80 to 84. Whereas after 1994, the computers entered into the transportation sector. So that's why they are giving it as a phase three starting from 1994 to. We will see one by one. The phase one from 1960 to 80. So a few milestones we are going to see here. In 1960, in Europe, Japan, China, Australia, and US all developed countries started developing complex system of broadcasting a code at the start of the message so that the cars equipped with such receivers would be able to get that information. So this is a primitive stage. So only they can able to communicate some kind of messages at some frequency. So there is a onboard equipment, like a radio kind of a setup was there in the car. So it announces it announces that some kind of information process. Okay, like a radio, it looks kind of a radio. So that is the initial stage in 1960s. Some traffic congestions or some incident happened, like accidents, that will be communicated through this network. But thing is, we cannot expect all the cars having this kind of setup, but the cars which are having this radio setup, they will receive the information, they act accordingly. Right, and the climate information and also the cause. In 1970, it's a major move. The Department of Main Roads in Australia installed a primitive system with 30 signalized intersections controlled by a central traffic control system. So this, I can say, it is the first initiation, the thought idea to create a traffic control center. So it is a centralized system where the signals are controlled from traffic control center. As a traffic control center means it's kind of a storage place or your office where your main server will be placed. All the data collected from there, you can receive input from the road, as well as you can give a output. That is some kind of changes we want to make in signal timings, you can able to make. So that kind of step, the major step was taken in 1970s. In 1974, a highway radio system in Germany used FM technology. You can see in this picture, a radio kind of setup is there inside the car for alleviating traffic congestion on northbound autobahns during the summer holidays. So this technology is mainly utilized only for a particular road, that is autobahns. We know the German autobahns, the vehicles which are going very high speed. There is no speed limit, they say, in autobahns. So for that northbound autobahns only they implemented this system, and especially for summer holidays where you expect more traffic. So that time they introduced this kind of a highway radio system. In phase 2, so now they are moving to the electronics and communication era. So several technological reforms in mass memory, the storage. Since the traffic, we know that enormous data you need to record day-to-day basis, even minutes, second-wise, is record the data and continuous 24 or 365 days. So huge data you need to store. So the mass storage devices are very, very mandatory. And you need to process the data, processing capacity and communicating systems took place in different countries during the second phase of development from 1980 to 1994. So the servers, the electronic servers came into picture. So in this phase, they can able to store the enormous data, but the analysis part is very, they were lagging at that time. The analysis only done by the human manpower. But there is also a major milestone, we can say, in ITS. In 1986, a program Prometheus for European traffic system was developed to improve the road safety. The focus is to improve the road safety. The program included participation of 18 European automobile manufacturing companies, state authorities, and over 40 research institutions. So you can see the stakeholders here. The 18 European automobile, they included the automobile manufacturing on one side, state authorities, the government authority on one side, other side, and over 40 research institutions also. So that is a collaborative step they took. The program named as Prometheus. The objective is to reduce the number of accidents. In 1992, ITS Australia, a non-profitable organization with various member organizations. This is also the same kind of setup, which included ITS suppliers. ITS, that is ITS related electronic manufacturing suppliers, government authorities, academic and transport business, the transport, the vehicle manufacturers or maybe a seller, and also users. All they included as stakeholders, and they formulated an organization called ITS Australia. Its main objective was to promote development and deployment of advanced technologies to deliver safer, efficient, sustainable transport across all the modes they included, starting from cycle, walking to the air transport, they included all the modes of transport. And they started to research, find out solutions for each and every problem. So the next, the phase 3 era is starting from 1994 to till date. So the computers are playing a major role till today. Several applications of ITS are being practiced, understood, and modified with reference to intermodal transportation facilities, including automobile traffic. So what is mean by here? The intermodal transportation facilities means, suppose if you are starting from your home, if you are going to work, you starting from your home, you are walking to your nearest bus stop. Okay, some from you are catching the bus and reaching a nearby metro station. Then through metro, you are traveling to your destination. From there, you are walking and reaching the office. So here, there are different modes are there. So starting walking is there. Then you are using bus. Then you are transferring to metro. Then again, you are walking. So you should have the proper connectivity between these all four modes. The walking should have a good footpath, okay, leveled, clean, and with the handrails. The proper footpath facility should be there, and the bus stop should be clean and neat. So the you are catching the bus, okay, and the frequency of bus should be good, so that even if you are getting bus and reaching the metro station, the bus entering into the metro station, so that no need to walk again. Okay, so we are catching the metro and traveling, and again at the end walk trip also you have a good footpath, the walkway facilities. So this is called the intermodal transportation. Let's see. So now the ITS is mainly focusing on now the perception is totally changed, not the movement of vehicles, but the movement of the people. That's why nowadays we are preparing a comprehensive mobility plan. So in olden days, we started preparing only the comprehensive traffic and transportation studies, where our objective is mainly the movement of traffic, the vehicles. But now the perception is totally changed. Now we are only focusing on the movement of people. How many people you can able to move from one place to the other place per hour? So that is our focus. So the IT is also accordingly changed. In 1994, the Intelligent Vehicle Highway System program in the USA was renamed as Intelligent Transportation System during the First World Congress held in Paris. So here only they coined the word called the Intelligent Transportation System. The word is coined here only. In 1991 only, before only they coined the word. So previously they were called with different names. So based on the development, given the name, whereas they coined a single name called Intelligent Transportation System. The word was coined in this conference. So in 1994, ITS Japan was established for promoting research, development, and implementation of ITS in cooperation with its 5 national ministries. So there is a collaboration with the different ministries, maybe a sustainable, the environmental ministry, transport ministry, petroleum ministry. So all the different kind of ministries, they collaborated and they worked in ITS Japan. In 1998, MIT, Massachusetts Institute of Technology's Microsystem Technology Laboratory. So there is a laboratory name called Microsystem Technology, established the Intelligent Transportation Research Center. They created a research center in MIT, and it focuses on the key aspect of ITS technologies, including an integrated network of transportation information, automatic crash and incident detection. So for that, they developed a network to find out any incident happen. So immediately how it will be transferred to the traffic control center, what actions need to be taken, okay, how the communication happens. So for that, they have done kind of a research. Okay, so applications of ITS in India. So the two major applications we are going to see the electronic toll collection system. So everyone knows now, whenever you are passing through a toll gate, there is a app called Fast Tag, through which we are paying our tolls. The electronic toll collection system, ETC. The second one is the coordinated signal control system. Coordinated signal control system. That is, we are going. We will see how we are going to coordinate and how it is applied. So first, the ETC system comprises of two components: electronic toll collection system. One is the onboard means. Onboard means in the vehicle, you need some kind of a setup so that the toll will be automatically detected, right, from the user. So nowadays in India, we are implementing the PPP projects, the public-private partnership projects, where the toll roads, they are collecting toll. Okay, they're based on the concession period. So for that, you need to install onboard equipment. Okay, along with the IC card. IC internal circuit card is there. So card is like a ATM card. So you can recharge the card then and there. So the IC card built in OBE, that's onboard equipment, will communicate with the roadside unit. So another component is on the roadside, on the road. So both will communicate. One is in the vehicle, the another one is in the roadside. Both will communicate at certain distances. So roadside unit is an electronic unit which is mounted on the ceiling of the toll collection girder. So whenever the vehicle passing under the girder, so the vehicle get connected with this electronic unit. Okay, based on the TSRC, there is a dedicated short range communication unit is there on the girder, so that automatically get connected with your OBE, that is onboard equipment, and detect the toll automatically based on the vehicle type. So this is how it is operating. It is an electronic unit which is mounted on the ceiling, that is top of the toll gate or toll booth, the collection girder, under which the vehicle, when the vehicle passes, so there is a dedicated short range communication. So the distance of this range is very short range communication, dedicated short range communication system. So that automatically connect to the OBE, is onboard equipment. So it detects the amount. So its operating frequency also given 5.8 gigahertz band active system. This is how the ETC system is operating. So wherever you are going through expressways or national highways, so we are using this. In India, we are calling it as fast tag. As soon as the vehicle approaches the toll booth, very close to the ETC filter, the DSRC detect the OBE, that is onboard equipment, and debits a preset amount from the IC card based on the type of vehicle and destination. So usually in India, that toll rates are collected for every 60 kilometers. So one toll booth will be there for every 60 kilometers. So for this 60 kilometer, it automatically detects a fixed rate. So what are the advantages? So it eliminates the traffic congestion. So in olden days, now also we are using the manpower. So but manpower, if you see the number of vehicles you can give a token is only for 240 to 250 vehicles per hour. For one booth, and able to, suppose if it is a handled or a person is sitting in a toll booth and collecting toll means, you can only give for 240 vehicles per hour in 1 hour. Whereas if you are using a ETC, the fast time, it can detect toll for 1,200. It's almost 5 times 1,200 vehicles. So almost 5 times the efficiency is higher. So the processing rate much higher. So they are naturally eliminate traffic congestion. So eliminate manpower. So automatically, since it's detecting only the traffic office, only a person has to sit and watch whether it is detecting properly or not. So it actually eliminating number of manpower, eliminate to handle cash and convenience. So no need to give a rupee and exchange. That is, you can avoid, right? So these are the major advantages of ETC. So next, the coordinated signal control system, where the basic principle here is a set of signals are there in a straight line. For example, 5 or 10, even the 10 signals are there. Then you can able to coordinate between the signals. That is, but thing is the signal should be in a straight line, straight path. For example, signal junction 1, junction 2, junction 3, junction 4, junction 5, like this. If I know the distance between the junctions, okay, say it is D. Okay, so if a vehicle clearing a green signal at this junction, so we know the distance. If we know the average speed of the traffic, then I can able to calculate at what time, at what seconds it reaches the next signal. So that accordingly, you can open the signal for that group of green immediately. So likewise, if I know the distance between the signals, I can able to pre-calculate, and accordingly I can open the green signal. For example, if the peak hour traffic is flowing in this direction, especially in the urban areas, then I can coordinate the signal in this direction in the morning time and reverse in the evening time, so that the bulk of vehicles, the huge volume of vehicles can be processed or passed over the set of signals. So this is kind of technology is called coordinated signal system. But what are the requirements for this kind of implementation? We need the signal and a local controller for each signal. On this, all these local controllers should be connected to a main server in the traffic control center. Okay, so each signal should be connected to a traffic control center, so that if I change a signal timing in the traffic control center, automatically the traffic signal timing will change a particular junction. For example, J1. Suppose I'm extending the green time, so automatically the green time gets extended in few seconds. So that kind of setup is there. Okay, then the coordinated signal control system is very much possible. So this is already implemented in many cities in India, but the requirement is the roads, the signals should be in a linear pattern like this. Okay, suppose if you have a episode road network and all, it is very difficult to coordinate. But if you have a grid pattern of road network, then if you have a linear junctions, linear way, then it is possible. And the distance between the junctions also should be within 1.1 kilometer, preferably. Then it is very much possible to coordinate the signals. So coordinated signal control system is the strategic approach to synchronize the start of green indications along two or more number of consecutive closely spaced intersections along a major street or corridor, which are designed with definite interrelationship of the green intervals. So this is what they do. The start of green indications can be coordinated. And it is a more strategic, where they are saying strategic means in the peak hour, peak direction traffic, I can able to move the traffic quickly. So the congestion can be avoided. It's a strategic step. And closely spaced intersections. That is also one of the important conditions. The intent of coordination is a strategic approach, so that group of vehicles can travel together as a platoon of vehicles. Means it moves as a group, the vehicles. So it passes an intersection, okay, and it consecutively passes all the intersections like a platoon, and are allowed to pass smoothly along the multiple intersections with a reduced travel time, minimum delay and stops. This is one of the major advantage of the ITs. As a result, since the congestion we are avoiding and air quality gets improved along the corridor considerably and also reduces the fuel consumption. Right. So we are unnecessarily saying signals are the major bottleneck for any corridor. Overall stream speed gets affected due to these signals. So if you have continuous signals, then traffic jams are unavoidable. So once traffic jams are there, then obviously it emits pollution, causes air pollution and fuel wastage, time waste, manpower cost. That is also waste. So overall economic growth. We can say how it is possible to see. We are seeing only in the micro level. If you calculate on a yearly basis, thousands of crores may be lost due to these traffic congestions. So that can be avoided. To achieve the above objectives, the following requirements are necessary. A coordination among the signal controllers with reference to a master clock. What is a master clock means? So all the signals should follow a same time. So each signal should not have different times. So then it is very difficult to coordinate. A master clock should be, the time should be set from the server. Okay, zero means all the signals should start with zero. It should be synchronized. The signal timing plan, that means the timing plan means the green time, how much green time for each direction you are giving, what is the amber time, that is called the signal timing plan should be there with you, or it should be stored in the server and should be accessible by the traffic engineer so that he can able to change the signal timing plan at any point. Equal cycle time. Equal cycle time means we know the cycle time means one complete signal rotation is over, that is one cycle. Suppose 4-arm junction is the arm 1 I am opening, green time, then amber I am giving, then arm 2, arm 3, arm 4. So all the arms I am opening green time. So that is one complete cycle. So normally it is 120 to 150 seconds we use cycle as a cycle time for one complete cycle of phases. So that should be equal for all junctions. It's a preferred. Say junction 1 to junction 10. Suppose if I cycle time is junction 1 is 150, then you keep 150 for all the junctions. Then it is very much easy to coordinate the signal. Suitable and adequate spacing between signalized intersections. So that is very, very important. Suppose if your junction is at junction 1 to junction 2, if you have 2 kilometer or 3 kilometer distance, then it is very, very difficult to coordinate. Okay, since some obstructions may come, some interference will be there, so that you cannot exactly calculate at what time it reaches the next junction. That is they call it as offset time. Okay, so that time you need to calculate exactly, and only you can open the next signal at correct time. So the vehicles move as a group. A time space diagram is drawn with the time on the x-axis and distance from a reference intersection. I will show you a time space diagram. Okay, the time is counted with reference to a master clock, a common clock. So in this picture, you can clearly understand. See, this is signal. Okay, this is signal 1. Okay, signal 2, signal 3. So here the green time. First I am giving a green time for the signal 1. Okay, so same clock is I am using. So the start and end times are same only. This diagram. So the distance is marked in the y-axis. Okay, so this is the distance between the consecutive junctions, and the x-axis I take time in seconds. So the first vehicle is passing through the first green line immediately after opening green line. So it takes some time to reach the next junction, and then again the first vehicle passes the next junction, and again it takes and it passes like that. This is for vehicle one. If you take the slope, that gives the average speed. Okay, distance by time. So if you take the slope, that actually gives the average stream speed of the traffic. So that's why initially I said the average stream speed, if you know, then it is very much possible to coordinate the signal between the junctions. So similarly, the lost vehicle, if I take, okay, so the lost vehicle, maybe the the lost vehicle passing. So similarly, it is passing. A group of vehicles can be passed through different intersections. So this line, they call it as a trajectory of a vehicle, the path of a vehicle. So vehicle trajectory along the length of the major corridor is represented by an inclined line. This inclined line is plotted on the time-space diagram. Then you can able to calculate what is the average speed. The distance between the successive respective intersections over the travel time, that is represented by the speed of the vehicle, is indicated by the slope of the inclined line, and it is represented by the operating speed. So before implementing this kind of a setup, you need to conduct a average stream speed. So speed delay studies, you need to conduct the site. So a test vehicle, you need to float along the corridor for which you are going to coordinate the signal. And based on the floating core method or some method, the speed delay study, you can find out what is the average stream speed. Okay, so based on the average stream speed, and if you know the distance between the junctions exactly, then you can able to calculate the offset time. Offset time is nothing but the distance by the speed, average stream speed. Right? Put then your one time you will get. So that is the offset time. But what time it is reaching the next junction. So based on the offset time, you can open consecutively the green signals. So you can move the vehicles continuously. It is very important that the plots on the axis should be to scale so that a consistency between distance and time units can be maintained. That is also they are saying. So this much while implementing these things, we need to take care. That means to the scale it should be. See, we cannot draw this time distance diagram without any scale. So then only if you take the slope, then you will get the average stream speed. So the axis, both the axes should be with some scale. Okay, one division is equal to this much. The vertical distance between two trajectories is the space headway between the vehicle, and the horizontal distance between the line is the time headway between the vehicles they are seeing. So the trajectory is I drawn, right? The first vehicle trajectory I drawn. So similarly, last vehicle trajectory I drawn. So if I take the horizontal distance, okay, since it is a time plot, okay, it's a time headway. So there is the time gap between the first vehicle and the second vehicle. Okay, if I take the vertical component, that is, it is a space headway. That gap between in meters that will be expressed in meters. The space headway between the vehicles they are saying. So these are the few applications in India. Apart from that, there are many applications out there. Okay, here I have only discussed only two major applications: IETC and the coordinated signal system. Apart from that, there are many applications out there, and major cities they have established a traffic control centers. They are monitoring the violating vehicles, and they are putting fines by SMS. You may be heard that thing. So if any vehicle is violating, automatically camera captures the registration number of the vehicle. It will be sent to the naturally, it automatically sent to the traffic control center. From there, a SMS will be sent to the driver or the vehicle owner. So you are violating the signal. So this is the fine amount. So this kind of technologies are there are there in India, in our country. And few applications in abroad. So public transportation priority system (PTPS) in Japan. So this is they introduced long back. PTPS means we are giving priority for bus transport at the signals, major signals. So the buses clear the signal immediately without stopping. So that kind of system is called public transport priority system. So red light violation detection system. So these two we are going to see. So PTPS, the Japanese PTPS system secures bus lanes and prioritize traffic signal for only bus movement through intersection. So there is a onboard equipment always there to identify whether this bus is given priority or not. For example, in Chennai, if you take the buses are mainly the government buses are operated by the MTC. So the MTC buses they install onboard equipment. So there's in the signal there is a sensor that automatically identify when the bus approaches the signal, it automatically identify and it extends the green time so that the bus clears the signal without stop. So this is the basic. So priority passage of buses through intersections and along specified routes is facilitated so that high volume of public transportation is efficiently. So the public transport buses will move with a higher speed compared to the cars. So imagine, say cars are need to stop in the signal. Okay, the two-wheelers are need to be stopped at the signal, whereas buses are given priority. The buses goes at higher speed compared to cars. So obviously, what people think they move to the buses since naturally it is going at a higher speed compared to a private vehicle like car. So that is the main motto of this kind of programs. Thus, the general public is encouraged to use public transport due to reduced travel time. So the demand for privately owned vehicles, taxis, individual cars can be suppressed, can be reduced. So infrared beacons installed at suitable intervals along any specified route. Suppose if you want to along the major road, we want to give priority for buses along the route, infrared beacons need to be installed at specified intervals that automatically receive some kind of information from buses using a specific ID. So MTC bus means you give certain ID, so it automatically receives a signal. Yes, a bus is commuting or passing through this corridor. It is approaching near the junction. Okay. So the buses are equipped with the in-vehicle units that communicate with the infrared beacons, and then this information will be sent to the nearby traffic control center, actually where they are controlling all the signals. They increase the green time for bus. With reference to the current location, of course now GPS are there. Through GPS also you can track the vehicle. Current location and average speed of the buses. So if you know the speed, then what time it reaches the signal, you can able to calculate automatically. So accordingly, you can open the signal head of or controlled by the traffic control center, so that the buses can go without stopping at the intersections. And in Ahmedabad, another good system they implemented, that is BRTS, Bus Rapid Transit System. They provided a dedicated path for buses. That is also kind of a priority. Also, they can they give a priority at the intersections also. Okay, so you have a 6-lane road. The one lane, complete lane, 0.5 meter to 3 meter lane can be completely given for buses only. So you can put barricade or fences so that other vehicle cannot enter into the bus lane. So buses only float along this route. Okay, so naturally the buses goes at a higher speed compared to cars. Okay, so that kind of things also have implemented in our country. The signal timings are controlled in real time to extend. Of course, the traffic control center, you can able to control the traffic signal, then it is possible to extend or shorten the green time. That is only possible only by if it is get connected with the traffic control center. So this system, the PTPS, the first PTPS, that is priority system. Actually, they implemented in Japan. But first BRTS project was implemented in Baroda. Yeah. So red light violation detection system, UAV, this is an enforcement system which is capable of automatically detecting. Suppose if any vehicle is violating the signal, crossing the stop line and the signal, it automatically captures the number of the registration number of the vehicle. Okay, there are speed cameras are there. Even if you go to higher speed, it captures the registration number, it's sent to the traffic number center. So the fine will be given sent by through WhatsApp or SMS to the vehicle one. The system comprises a loop sensors, digital and analog cameras, signal lighting sensors, network devices. These are various components which are needed for red light pollution detection system. The loop sensors which are installed on the road detect the vehicle. There's a presence of vehicle has to detect, right? So its speed also it calculate. A high resolution digital camera captures the license plate. The digital camera is having high resolution, so it should be accurate. So it should be clear. The license plate should be clear. So all the registration plate details should be there in the traffic control center, so that automatically you can send the SMS to the concerned mobile number. A secondary analog camera is also installed to record the image of the moving vehicle. So whichever vehicle is crossing the red light, also with another camera it captures the image of the vehicle as the evidence. So these are the red light violation detection system. The other technologies, you can say the global positioning system, GPS, day to day we are using in our mobile phones. And for even the public transport buses, you can track using GPS. And where is my train? There is an app is there, Indian Railways. So using GPS, you can track where is the train. So accordingly, you can plan your trip. So this is very all modes we are using the GPS. Okay, so even the booking of taxis, we are using GPS. Unavoidable technology, one of the major technology. And traffic simulations. So the computer, since it's a computer era, so traffic simulations plays a very important role. Like we see, so visual simulation, that is one of the software, simulation software, where you can simulate any kind of conditions. For example, if an intersection, if you want to plan to construct a flyover, so you can simulate. Okay, even the vehicle sizes, dimensions, exactly to our Indian conditions, you can able to simulate the traffic. If you know the road geometry, if you introduce suppose if you are planning to introduce a flyover, what is the impact? Okay, how much travel time is going to save? How much fuel is going to save? Whether it is worth to invest or not. So this without directly implementing inside, you can do the simulation study before implementing and find out whether it is feasible or not feasible. So accordingly, we can take decisions. So traffic simulations are very, very helpful nowadays, and even major projects, even the government is requesting to submit traffic simulation output as a justification. So the problem is here in India, we have a different kind of vehicles out there, starting from cycle. Of course, the cycle percentage is now very lean. Two-wheelers, cars, and different kind of cars, buses. So each mode travels at different speed, acceleration, deceleration, behavior, sizes. So everything is changing. So we are highly heterogeneous. So for each every vehicle type, we need to create that is models for simulating. And similarly, the traffic, the road patterns, the road is not, it will not be uniform. The width may vary. Okay, suppose for 5 kilometer, if you want to do a simulation, then the entire 5 kilometer, all the road width is varying, the complete plot, or even using a Google map, completely withdraw, then you can find out actual count. If you know the volume count at the site, then you can simulate the traffic. Okay, it is a little what I think it is more laborious job only. So the site investigation need to be done, traffic data inside you need to collect, then you give it as a input, and the whole geometry of the road network you need to give as input accurately. Then it gives accurate result. Next, the WIM technology. So this WIM means the way in motion, they say. Way in motion. The way, see, nowadays, what they are saying, the weight of the vehicle, how they are measuring the axial load. Axial weights, the roadside weighing machines are there. So there only we are weighing the axial loads. Okay. Actually, when the vehicle is in the movement, we can measure the weight. So such kind of technologies will come in future in our country also. So this is very, very helpful in PPP project. Why I'm saying is, for example, you are collecting toll for two axle truck, 50 rupees. Whether it is loaded or unloaded, for both the truck we are collecting same amount. But actually, the loaded truck causes more damage than the unloaded. Right? So based on the load only, we can charge or collect a fee based on the vehicle damage. That is payment damage. So for that, the WIM technologies are very much helpful. Okay, the WIM technologies, there are piezoelectric sensors are there. When the wheel passes over the sensor, it automatically calculates how much the axial load is. Okay, or kind of a weighing bridge using a load cell. So you can install along all the pavement, across the pavement before the toll plaza. Okay, if any overloaded trucks also you can find out. If any overloaded truck is passing, so you can find out what is so you can stop such kind of violating vehicles. Okay, you can ask them to unload. So these technologies are very much helpful. Sooner or later we will see this kind of technology in our country. Adaptive traffic control system. So this is purely a artificial intelligence kind of thing. So no manual interference. So based on the queue length, automatically the CCTV cameras captures the queue length of a traffic stream. It does the image processing. So automatically it extends the green light based on the queue length. Okay, so that kind of traffic signals are called adaptive traffic control system. Okay, so this here no manual interference. So everything happens automatically. That's why it's called adaptive. Based on traffic length, queue length, automatically it adjusts the green length. Next to the autonomous cars. So autonomous cars, it is in pilot study only, and it is not implemented anywhere. So without a driver, based on purely sensors, it will predict and automatically navigate. Okay, automatically navigate without making collision with any vehicle. So it moves. It is autonomous, completely, no drivers. And the recent newspaper article also, we saw that Chennai Metro Rail is planning to introduce driverless metro trains. So without driver. So of course, metro rails are moving on tracks. So it's more safe, whereas in autonomous cars are moves on the road. So vehicle to vehicle. So vehicle to vehicle talking may take place. Okay, the vehicle to vehicle interaction may take place. So without making collision, it automatically adjust the lanes. Okay, and there's using cameras. We can process if the signals can be identified by the vehicle. So when there is a red signal, it automatically stops. Okay, when it is green, again it starts. So in future, this kind of vehicles will come. So a short video we are going to see on the autonomous vehicle. So I can copy paste this link that I hope you have seen the video, the short video on autonomous vehicle. There are so many videos in the YouTube. Okay, so thank you. You have any doubts?
Participants, if you have any doubts, can
Please.
unmute your mic. if you have any doubts, you can directly ask the speaker. Yeah, some of you have raised their hands. SMIT civil. Do you have any questions, Ganesh? SMIT civil. So participants, if you have any doubts, you can ask now. So I think there is no.
Yes.
Yeah, yeah, ma'am. Lata Ganeshan, ma'am. Sir, there is a question in chat box.
So ITS is applicable. Yes, of course, rural areas means the national line is like all rural roads only. But rural means village side you are there. See, the thing is, whenever the traffic management is necessary, so you have a traffic problem, some issues are there, so then only you can use this kind of technologies. Okay, whereas the rural areas, most of the rural areas, you see the traffic problems, traffic and congestion kind of problems may not be there. Of course, if any issues are there, for example, the incident, some accident, reduction, safety point of view, we can develop best technologies. My thing is now in civil engineering, our students are doing projects, final year projects. So they are doing only focusing on civil engineering. So they can collaborate with the other departments like electronics or computer science, IT students. They can do a joint work. They can develop this kind of technologies using sensors, some models they can produce. So even they can present it in hackathon kind of thing. Okay, so in that kind of initiatives as a teacher, is it applicable for emerging new technologies such as bots? Can you expand what is bots? Yeah, the loops, you can say this loop technology we are using in traffic, the loop detectors we are using for finding out, counting the number of vehicles or the number of axles. So any other doubts? Okay, thank you very much.
Thank you, sir.
Thank you.